This is class lesson 3.2, part 2, domain and range. We are going to be sketching the graph of a function and then using that graph to identify the domain and range of the function. So a lot of different ways you can do this. We're going to do it by just plotting a few points and then taking a look at what this graph represents. So the first thing we want to notice is that both of these are linear. Okay, this is a linear function. And this is a linear function. And where we have this separation is at -2, at x equal to -2. And I'm going to get rid of this line in just a bit. But I just want to make sure that you're aware that this function is when x is less than -2. And this function is graphed when x is greater than or equal to -2. So let's first look at this top piece of the graph. So x plus 1. So that is a line that goes through 1. When x is 0, y is 1. And it has a slope of 1. So up 1 over 1, up 1 over 1. And also in this manner like that. Now remember, we only want this graph when x is less than -2. So what we'll do right here, now here we're going to just get rid of, I got rid of both of those, but that's okay, is have an open circle here, and then we're going to connect all of these points. So we just then erase this again, and I can put that line back here. This is where that piece changes, okay? Now let's look at this next function. When x is 0, so if you would look at f is 0, we're going to have -2 times 0 minus 3, so the y value is -3. So here we have a y value of -3 when x is 0. And then we have a slope of -2. So it's down to over 1. Or you can also go up to and to the left 1, up to and to the left 1. And here we want to include that point. So now let's connect those. And that's what we have. There is our piecewise function. And I can get rid of this -2. We could also show a couple other points. Let's plug in -2 right here to verify this point. You could have also done that. So f of -2, and that would go in this second piece, is -2 times -2 minus 3, and it's 4 minus 3, and that's equal to 1. So the point -2, 1 is on the graph. And you could have put that point there as well. So now let's go to the domain and range. And again, there's many different ways you can do this. So our domain, look at that, all real numbers, even -2, because it's solid here and open here. So -2 is still part of that domain. So our domain is all reals. Now let's take a look at the range. We need all the y values until we get to y equal to 1. And we do want to include it, but we don't want anything higher than that. So we're going to start from -infinity and go all the way to 1 and include 1. Okay? Now let's go to number 2. In number 2, you can see we have a quadratic here, and you may or may not recognize that, but this is f of x equals x squared and 1 minus x. And this change is going to happen at x equal to 0. Now, neither of these graphs include 0. So why don't we just start with the less than 0 part right here and try a few values. So f of 1 is 1 squared, which is 1. And actually, that would be on this next piece. Let me go down there. Greater than 0. So f of 1 is 1 minus 1, which is 0. And then we could try f of 2, which is 1 minus 2, and that's a negative 1. And we could try f of 3, which is 1 minus 3, and it's a negative 2. So now you can see this line, and we want to not include 0. So we're going to have an open circle here, and we're just going to come through like this. Okay, that's the right piece. Now let's do this upper piece. So that's that lower piece. So where x values are less than 0. So let's try f of negative 1, f of negative 2, and f of negative 3. And what you're noticing is this function squares its values. So we have a negative 1 all squared, and that's a 1. We have a negative 2 all squared, and that's a 4. A negative 3 all squared, and that's a 9. And all of this is going to occur when x is less than 0. And this other piece was greater than 0, okay? So now let's go to the other side. Negative 1, 1. Negative 2, 4. And we really can't go up higher for that third point, but we know that it's going to be steep. So why don't we try plotting this, maybe something like that. And we don't want to include 0. That's sort of what it looks like. Okay, let's look at our domain. All of these x values, but not 0, and all of these x values will be taken up. So 0 is not in the domain. And you can see that right there. So our domain is negative infinity to 0, unioned with 0 to infinity. Now let's look at these y values. Take a look at these y values. So we're going to have all the way from negative infinity. Y equal to 0 is taken up, and y equal to 1 is also taken up. So this includes all y values. So the range is all reals. Okay? Even though this has an open circle here, it's filled in over here at a different x value, has that y value. Okay, let's look at our last. Let's take a look at number 3. The height h of a projectile is a function of the time t that it is in the air, and the height in feet for t seconds is given by this function. First of all, you can see that this should just be t squared. Okay? So basically, we have a projectile. It goes up into the air and it lands back down. Now we know that at the beginning, t is 0. And let's plug in 0 to see the height where it is at time 0. So h of 0 is negative 16 times 0 squared plus 96 times 0. Well, all of that is just 0. So the height is 0 on the ground. So then it's going to go up in the air, and then all of a sudden it's going to come back down to the ground. So what we know is that there must be another time when the height is 0. So let's see when this height is 0. So 0 equals negative 16t squared plus 96t. Let's see if we can factor out a negative 16t, and we have a t minus 6. Then solving that, either negative 16t is equal to 0 or t minus 6 is equal to 0. So t is 0 or t is 6. So here we go. We're on the ground at t equal to 0. And then we are back on the ground. It goes up in the air and back down, and we're back on the ground at t equal to 6. Okay? So what is the domain of the function? Well, the domain is going to be the time, which is 0 to 6. What does this mean? Well, this means, the domain means it takes 6 seconds after being launched for the projectile to return to the ground. Okay, and that ends this part of section 3.2.